Welcome to Webinar Wednesday, GED Science 5 E's for Effective Instruction. I'm Bonnie Goon, and with me today is Susan Pittman. June Rawl, Director of Florida IPDA, is on the road traveling, so she will not be with us, unable to join us. But as we start today, let us just show you something that June would have shown you in a previous webinar. And that is the fact that although today's workshop focuses on how we can create effective science lessons for the classroom using the 5 E's, there's so much more that we can access on Florida IPDA, because many times we don't have the materials that we need. So just to get us started thinking a little bit, let's talk about a few of the resources on the IPDA website that can assist you in teaching. If you go to the GED and AHS tab on Florida IPDA, when you open it, you'll see all of the various resources developed for the GED classroom. So if we're looking specifically for science, first of all, there are webinars. And please note that all of the webinars are recorded and archived. In fact, today's webinar is also being recorded and will be archived to the Florida IPDA website. In fact, you'll be able to access this as early as tomorrow. But besides all of the very different webinars that have been presented, don't forget that there's Florida's Instructor Handbook for GED Preparation. If you go to that specific handout, you'll notice that there's a chapter on strategies for science. The other thing to remember off of Florida IPDA is sometimes you may not get to go to those workshops that you wanted. All of the workshop materials are posted on this website. You may wish to take a look at Scientific Minds Want to Know and the Wonderful World of Science. But that's not all. There are also science lesson plans, grab and goes, everything that you need to teach a lesson. In fact, the grab and go and experimental designs is a great one to get started integrating an inquiry-based process for science. Make sure that you spend a few moments reviewing these exciting resources. As always, it's by the field, for the field. So Susan, let's get going with today's webinar. What are we going to be doing?
Well, there are a number of different things that we're going to be doing as we move through. And first of all, we're going to take a look at some of the content that we need to think about including into our science classroom. Now, Bonnie and I know that all of you out there don't necessarily have a science lab that you're working in, but we can take an adult ed classroom and we can turn it into that science classroom where students can explore a number of different things. And that brings us to our next topic, exploring. We're going to explore something called the 5 E's. And it's kind of a research-based lesson planning process where we can help to make sure that students are getting the most from the limited amount of time that we have to work with those different science topics. Remember, we want them to be able to take information that they learn in our classrooms and move out into the real world and on into post-secondary education. So let's keep that in mind. And then last but not least today, we're actually going to go through a couple of options for you, how you can apply the 5 E's to hands-on lessons themselves. So let's kind of take a look at this kind of overarching theme of science content and what that really means in terms of that. Now, keep in mind, if you haven't looked at it in a while, you might want to go back and check out the GED Testing Service Assessment Guide for Educators, because it actually gives you kind of an overview, plus really can help you dive deeper into the content of the GED test. However, we have to keep in mind that we have two things in play here. One, those are focusing themes. And those are the items that kind of allow us to come in and be able to narrow the field a little bit, especially when we think about science and how much that includes. But we also have something else, and it's called science practices. And those science practices are things that go beyond any one area, whether it's earth and space science or looking at human health and living systems. It takes us beyond that, but looks at those really high impact indicators that we've talked about in previous webinars. What we really want students to be able to do is we want them to take and apply skills of science so they can understand scientific concepts. So that's a big part of what we want to do as we're moving through. So let's take a look first at these focusing themes. And so as we move on to this next slide.
Susan, where can I find them?
Oh, well,
Susan, where can I find them?
Okay, the guidebook itself that you have, that you downloaded, hopefully you pulled the handouts. If you didn't, they're on the side panel, so you can actually pull those down now. But if you were to take a look in the guide itself, what you'll find is you'll find this same chart called Scientific Themes or Focusing Themes. So that's included in the book, but also remember that assessment guide, there's also information that's included in there as well. So let's take a look at terms of two focusing themes. And remember, everything on the GED test in the area of science falls into one of these two areas, either human health and living systems or energy and related systems. So what that does is it allows us to kind of narrow in our focus whether we're working in life science, physical science, or earth and space. So we could take a look, say we want to take a look at energy and related systems. Well, we know that everything requires energy, whether it's the human body and the energy that's required for life functions and how we expend that energy. Or if we're looking in the physical science area, how do we conserve or transform energy? What are those things called work and motion and forces? Last but not least, where does that energy come from? We can talk about Earth and its system components and looking out at the sun and all of the different things associated from there. Again, each one of those two focusing themes is applied across all three content areas. But remember, we said that there's not just the focusing themes, but there's something else, and that's called high impact indicators, or really it's practices. It's things that you could do across any of the different areas. And this is in your guide as well. In fact, it's on page 3, and there's a little bit more information that you can find within that. So remember, if you haven't downloaded those handouts yet, make sure that you do, and they're on that right-hand menu side. So let's talk about practices. Well, we have this big word out there called hypothesis, or hypotheses if we're looking multiple ones. But our students need to understand, well, what does that mean? What is a hypothesis, and what am I going to do with it? What is a scientific investigation? Let's face it, most of our students that are out there really don't understand how scientific investigations actually work. How do you move from having an idea to flow all the way through to see if that idea actually worked or didn't? You remember those two little words, if and then? If I did this, then would this happen? Well, that's how you do a scientific investigation. And as you take a look at these different indicators, you see a number of different things here. I see one, Bonnie, that's included in here. It's the second one where it talks about independent and dependent variables. I believe, Bonnie, we talked about those types of things when we talk about mathematics and how one thing impacts or another one, where we have something that's dependent on something else happening. But there's also more. It's about evaluating. Can I look at the data that's provided or the evidence, and can I draw a conclusion from that? And is it supported not just by what I think about something or maybe what I've heard, but what that data actually tells me. And then how do I express those scientific information or findings visually? Remember, folks, that when it comes to working with mathematics, it's not just the mathematical reasoning test that we are concerned about. We also find different parts of math that are included within science and also social studies, which we talked about last week. And then last but not least, can I apply formulas from scientific theories? Could I determine that answer from there? So let's talk a little bit about how we get there. Because one thing we all know is that the GED test is a lot about reasoning. That means thinking. And as Carl Sagan said, science is a way of thinking much more than it is a body of knowledge. So when you're concerned in the classroom about how can I cover all this science topics, I want you to go back and think a minute about how are you going to make sure students have the critical thinking skills or the reasoning skills that allow them to work against different content areas. So there's a process that you can use. And Bonnie, can you tell us just a little bit about 5 E's and what these things are?
Definitely. And as Susan said, there is more than just reading an article and answering questions in science. Rather, students need to know those basic scientific theorems, basic scientific formulas, and even more importantly, how science works. So the 5E instructional model provides us with a format for lessons that builds on what students already knows and goes that next step. And what 5Es do is it gives us a sequence so that the learning experience for students not only starts with their understanding of a concept, but builds it over time. Each of the phases can be described using 5 words, and of course it stands to reason. And those words start with E's. We're going to engage students. We're going to have them explore. We're going to explain things. This is really where we introduce that conceptual knowledge. We're going to have them elaborate, and of course, we always want to evaluate. What Susan and I want to do is take you through the process first and show you what kinds of things you should be thinking about when you're developing a lesson plan based on the 5 E's. Then we're going to provide you with samples in the different content areas so you can see what it would look like in the classroom. But first things first, let's look at each of the E's for a little bit. And we're going to focus on what it should be doing in a lesson plan and some sample activities, and then focus on what you as the teacher would do and what we would want the student to do. Know that all of this information, as we've said before, is in your guide, but for now, let's talk a little bit about each of these slides. When I engage my students, I want to make sure that I've created some interest and curiosity. I want to capture their interest. I want to set the stage. And so maybe I do this by a demonstration or an experiment, or maybe I have a picture or graphic of something, or maybe we do read some article or some short synopsis of something. Maybe I even brainstorm with students. Have you ever seen this before, or what do you know? And of course, we always have things like KWL, accessing background knowledge. So as the teacher in the engage segment, I do want to create interest and generate curiosity. I want my students to raise some questions, and I want to be able to uncover some things they know. And it may be something as simple as, if I'm doing a demonstration or experiment, asking my students, why do you think this happened? What do you already know about this? Or what have you found out about this if they've read an article? And I want my students to definitely show interest in what we're doing. Science should be a lot of fun. Sometimes it doesn't seem so to students, but there are so many things that we can do with it. So to get started, we engage. The next step is we want students to explore. This is the time where maybe they have an activity, maybe they have a problem. Maybe we ask them to collect information about something. And in this, again, we may perform an investigation, or maybe they read an authentic resource and they have to collect information, something we would call evidence in some of our other areas of GED. Maybe they solve a problem that we set up there. What do you think would happen if? Or for some of our students who are very visual learners, maybe they construct a model. I can't think of how many times we've had students construct models of the solar system, but maybe it's something a little more creative than that. So as the teacher, this is that time when I want to encourage my students to work together. I want to ask them probing questions and observe and listen to what they do. You know, this is the time for students to persevere or puzzle through the problems that we're given. And so what do we want to see students doing? We want them to think freely, but of course within the limits of the activity. We don't want them way out there. Maybe it's the fact that during this time we have them test predictions and we have them hypothesize. And if that doesn't work, we have them create new predictions and new hypotheses. This is where we could have students doing an experiment and recording their observations and ideas. And of course, we want them always to suspend their judgment, because sometimes in science, what we think will happen really doesn't. And some of our rationale is not always accurate. The next is to explain. And this is where we want to have an activity for students that they can analyze their explanation and that we make sure that their understanding is correct. We want them to, again, maybe read and discuss. This is the time when, as a teacher, I'm going to do some explanation to students. So if students can't explain concepts and definitions in their own words, this is the time that me, as a teacher, will provide them with additional information so that what we end up is from previous experience, from current experience, and from predictions, they understand some things. And so as we're doing this, this is oftentimes what we see a lot of in our classrooms. We're going to continue it under explain. It's going to be a part of the whole. Another E is to elaborate. After I know the basic concept, or after my students do, I want them to go further, because they may never see that specific experiment or that specific article or definition. So I want them to expand their knowledge and apply what they've learned to different real-world situations, because let's face it, science is everywhere around us. So this is where students are going to, again, do experimental inquiry, maybe some thinking activities. This is where, as the teacher, I want to transition what they know and transfer it to other different situations. I want students to see, as Susan said before, work, energy in different scenarios. I want them to be able to use that information to draw reasonable conclusions from evidence and to check their understanding, not what they understand alone, but also what their peers may understand. And then, of course, we know we always have to evaluate. And Susan and I have often said there is no better evaluation than what we as teachers create to use in our classrooms. So don't forget, you could use previous activities, or you could develop your own scoring tool or rubric. Of course, there's tests out there. But know that producing a product, journal entry, teacher-made assessments are really the best. So what would you do during the evaluate segment? You're going to observe your students. You're going to assess their knowledge and look for evidence that they've changed their thinking or behavior. And you're going to ask as many open-ended questions as you can. Those why, those what, those how questions. Because if our students can answer open-ended questions, then we know that they know it. And we want them, again, to evaluate their own knowledge. So that's a brief overview of those 5 E's and some of the specifics that we're going to look for. As a teacher, there are a lot of different ways that you can lesson plan using the 5 E's. Something as simple as a graphic organizer where you're just creating some ideas and some questions for each of the 5 E's, or accessing some lesson plans that apply the 5 E's already for you. That way, you can say to yourself, now I know how to get started. So what Susan and I are going to do for a moment is we're going to take you through a couple sample lesson plans that use the 5 E's. And we're going to
Bonnie,
tell you up front. Yes.
Bonnie, I'm going to interrupt you for just a minute because a couple of things I want to bring up to people who are out there is, one, as you looked at those 5 E's, you may have said, oh my Lord, I'm going to spend all of my time trying to teach science through these 5 E's, because it can, when you first look at it, look a little rather daunting. However, it really isn't. And I think that as we go into this next part, you'll really see how simple things can be as we work through the process. But there's one other thing. Most of us who are in the classroom, we're not science majors. That's not our big background. And so sometimes it's knowing, what questions do I need to be asking? What are the specifics? And one thing I want to make you aware of is that in your handout, in the book itself, on page 8, you'll actually see the 5 E's to encourage discussion. And within each of those different areas, you're seeing questions that you can ask at that particular point in time. So again, these are resources that will be helpful to you as you're moving through the process. But I think the other thing is to understand that this is not something that requires that you spend inordinate amount of time in trying to go through and teach the science, and much better to do a few lessons with greater depth using the 5 E's than to try to cover a lot of short mini topics. Because again, remember, we're trying to get students to learn not only the science, but can they understand the reasoning skills? So that's a part of what we want to do as we move through. So Bonnie has put together a really fantastic lesson here that's energy and related systems. Remember, we've got those focusing themes, and we've got now the 5 E's. So we're going to take you through and let you see how to do that with this simple lesson that's on energy and related systems. Now, it can go into a whole bunch of other areas if you want to take it there, but it's certainly not something that you have to do. So this particular lesson itself, we're going to start with engage. And for some of you who may have seen Bonnie and I doing some training, you may have remembered a time, or maybe you saw a KET video where we talked about what would happen if I had an orange in one hand and a grape in another. If I were to drop them at the same time, what would happen? Well, that's the engage part. It's about opening up students, asking them questions, and as Bonnie said otherwise, getting them to connect. Okay, so I'm standing in front of the room and I've got this orange and I got this grape, and oh, well, I can have students, then they start predicting, hypothesize. What's going to happen? Which one's going to hit the floor first? Why? Why do they think that? And then from there, moving them on into actually seeing that demonstration, and from that demonstration going, whoa, wait a minute, something's different here. How did this change? How is this possible? Now we've engaged them in that whole process with science and beginning to look at Newton's laws of motion and beginning to see, oh, there's something else at play here. So how do I work with that? So again, simple. And of course, all you have to do is grab an orange, grab a grape, and you're good to go. This lesson plan is on Florida IP Day, so you can always go back to that, but we'll also refer you to some of the other things in the workbook as well. But you have to have another part. And Bonnie was talking about that as she was going through, and it was about exploring. Okay, we've engaged students, got their interest with the orange and the grape. Now let's try something different. And quite honestly, in your classroom, you can't come across any materials that are any cheaper than a couple pieces of paper. And so what do? We're going to look at how does air resistance affect the acceleration of falling objects. Oh, boy, doesn't that sound fancy. However, it's a simple process, but one now that students can explore themselves. Quite honestly, all they need is a smartphone in hand with their timer and a group of people working together to do an experiment, simple experiment, where they're going to time different paper foliage that is moved into different shapes and see which one takes the longest to hit the ground and which one is the fastest, and then talk about why. The idea is to get that to understand what air resistance does to different types of paper, whether it's flat or it's crumpled up, and students get to use their own imagination here and their own creativity and develop their own design. And you'll see that that's included also in guide the page 10 and 12. Well, now it comes time for me as the instructor to go in and say, okay, let's do some talking, because there's a reason why these things happen. And explain now becomes my part of that lesson in terms of conveying information and getting them more connected. And we start looking at Newton's 3 laws of motion. And, now we're even looking about this relationship between an object's mass, m, its acceleration, a, and the applied force. So now we've got this formula going on. And, sometimes we can explain things, but sometimes a short video is a great way to do it as well. And I know that Bonnie found this wonderful little video. It's called The Best Idea Ever, that you may want to check out as you're moving through. But we can't stop there. We need to go a little bit further with this in our explaining. And now we're looking at the second law of motion. And what a great visual we have here, that we have this elephant and a feather, and they're both dropped off a very tall building from the same height at the same time. And if air resistance could be eliminated, what would happen? Well, the students now have had that experience with the grape and the orange. They've had the experience working with the different kinds of paper. Now we know that air resistance is out. How does that impact? But then as we look to the next one, we see that we also have them dropped off a very tall building, and it's a realistic situation that both the feather and the elephant encounter air resistance. And so what happens as a result of that? So again, different ways that we can help students understand Newton's law of motion. And it's not that we're trying to have students memorize anything, but rather that they see this application that first it's funny to see the elephant and the feather, but also it represents something much more real to them. But along the way, you saw a couple of things that were included in here, and it was called vocabulary. And we have to make sure that our students have the vocabulary of science, so that if someone talks about force, they're not thinking of force in another terms, but what is this? And force and object, mass, acceleration, all of these different things. So, and notice that Bonnie has included here a couple of graphics that students could see. What happens in different situations if the forces are balanced or they're unbalanced? Again, we're not trying to teach everything, but we want to make sure that students get the big ideas and that they have an understanding and can reason through those. So now we can elaborate, and that means we go over and we try something different. Would a tennis ball or bowling ball require more force to throw? Oh, got to think about that. But what would our students have learned from what we've done in the different components of the 5 E's? So now you can take a look and see that we don't have to make this incredibly complicated as a part of the process, but what we can do is actually get students to see things in more of a real life context. So how would we evaluate? Well, the students could draw a picture, they could write a summary, or maybe they're going to get up in front of the class and demonstrate an example of Newton's second law of motion, and then how it applies to everyday objects. Those are the kinds of things that we can do within the classroom that we wouldn't necessarily do everything in one set lesson, but maybe we could work in some time over a couple of classes in order to work with this, because it really is all about getting students to think, to reason, to predict, to have a chance to do some exploration of their own and work from there. So that just gives you an idea from energy and related systems, looking back at the physical science. But Bonnie, I think you've got something that deals with chemistry as well.
Definitely. And as Susan said, many of us may not be science majors, but there are so many great resources out there on the World Wide Web that all we really need to do is a Google search for those big ideas we want to teach. And I guarantee you're going to find so many things. Like the elephant and the feather, we've given you the URL for the physics classroom, saying, oh my goodness, I'm not so sure I know how to teach chemistry. Well, we know there are some basics of chemistry we need to be teaching, such as matter, solids, liquids, and gases, changes of state, density, periodic table and bonding, water molecules and dissolving, and chemical changes. And there are lesson plans that have already been written for us using the 5 E's. One site that you may wish to look at is called the ACS Chemistry for Life. Don't let the middle school chemistry throw you off. So many of these topics are really excellent for our adult ed classroom, and because it covers the 5 E's for us, you have everything you need to teach a lesson in these areas. So all you have to do, go out to the URL, take a look at those big ideas, and get started with the 5 E's. But we talked that there were a couple other areas or content areas. One of them is human health and living systems. So how do we do the 5 E's using human health and living systems? Let's look at a couple other great resources for the classroom. If you've not looked at TED Ed, you may wish to go out and sign up so that you know all the latest, greatest videos that are out there. Developed by teachers, they're amazing. So one of the areas of human health would be the area of antibiotics, diseases, those real-world experiences. So we just happened to find this wonderful video on bacteria versus antibiotics. And I guarantee that if you ask students for real-life experiences, how many of you have ever taken an antibiotic? What happened? And then show them this short video and have them find out the who, what, when, where, and why of the video. You have your E, engage. Then next, you could have them go ahead and take a look at an article that goes a little bit deeper into antibiotics. And there's a great one out there from the Huffington Post by Karen Natterson, where Dr. Natterson compares the two sides of the argument, the argument for prescribing antibiotics and the argument against prescribing antibiotics. Kind of sounds a little bit like the kind of evidence that we'd want to gather in RLA, which is transferring that skill to science. So here again in the exploration, students have the opportunity to, on their own, read pros and cons, discuss well, gosh, I like this side better, or I like that side better, and even construct their own argument for or against prescribing antibiotics, where maybe what we have at this time is having them read an article and identify different pieces of evidence for, different pieces of evidence against, and have them write a sentence or two where they say the pro side or the con side is better supported, and here are two or three pieces of evidence supporting it. That's explore. I can also get into explain. As the instructor, I can lead students to identify and summarize the major ideas in that narrative or in the video. We can talk a little more fully about vocabulary terms that we heard or read about, really taking them to that next level down. Maybe having them do some type of a graphic organizer where they have to define those terms in their own words, provide examples, non-examples, etc. And again, we can talk more about the cause and effect of overuse of antibiotics, and maybe even having them predict what they think would happen if a person takes the same antibiotic 6 times in 1 year. I guarantee that some of our students know all about antibiotics, and either the person or someone in their family may have taken an antibiotic more often than was, positive and gotten something called antibiotic resistance. Again, what we're trying to do is explain more deeply this one science topic. Now, because they're not going to see the same test questions or the same source materials on the GED test, we want to elaborate or extend their knowledge. So I can do something as simple as set up a different type of scenario. And this is one that we obtained from TED Ed. It says, imagine that you have a farm and you raise livestock. Using information that you learned from the video as well as additional resources, decide whether you would give all of your livestock antibiotics as a preventive measure. And the student has to describe why or why not. This really does extend that topic that we're trying to teach. Then, of course, we can go into that next level of evaluating, where we have students design an experiment that will measure when people begin to feel better after taking antibiotics, and if they should stop them as soon as they feel better, or if they should continue, and to give evidence to support. Now, what you'll find is, again, if you go to Florida IPDA, you're going to see a lesson plan. And although it is not developed specifically in the 5 E's, I think you'll notice that you will see those 5 E's throughout that specific lesson plan, and that it does cover each of these items. So teaching the 5 E's sometimes is not real blatant that we say, okay, here we're going to do the explore, here we're going to specifically do the explain, but rather that lesson plan does incorporate all 5 steps into a whole. So another lesson plan in human health and living systems. But we have another area of human health and living systems, and that happens to be Earth and space science. So what can we do for a sample lesson plan in Earth and space science? Well, maybe we create an experiment for students to use, and maybe we talk about those areas of erosion and transportation and deposition by creating a physical model. Sometimes, as Susan said, we don't have a whole lot of access to materials to do an experiment, but it doesn't have to be difficult. Take a look at these materials: a paint tray, pieces of sod, potting soil, a heavier soil like clay, a rainmaker, a fancy word for a paper cup with about 10 tiny holes poked in the bottom, and water. Very inexpensive, very easy to access. If I have those materials, I can teach my students an Earth and space lesson using the 5 E's. And I can start with something as simple as taking them on a walk outside of the school building and having them notice where that soil is worn away or seems to have collected, and have them make a list of those sites and asking such questions as, Do you notice anything different about these areas, or what do you think caused them? And I can think of a number of things, Susan, that could have caused them. I mean, maybe it was a heavy rain. Maybe it was the fact that we have students who always take that shortcut through the grass. But again, a lot of ways to engage. Remembering what our goal is to teach such things as transportation and deposition. So then I want students to explore. And maybe when they explore, they construct that model. So I'm going to provide them with the materials that we saw on that first page so that they can construct their own model of the landscape. They can use that paint roller tray as the base of their model. Just tell them they shouldn't put any landscape materials in that bottom well there. They're going to use that a little bit later. So after they've constructed a model of their own personal landscape, maybe it's very flat, maybe it's got different curvatures, but then we want them to put a full glass of water into their rainmaker and slowly move it over that model and observe what happens to their landscape when rain occurs. And I'm sure if your students are like Susan's and mine were, some of them would have that whole landscape just kind of move all the way down to that well because they had just kind of really put it in a huge pile. But after that, explore. That's when we want to get into the real crux of the lesson. And that's in the explanation, asking our students, what were your predictions before the rain happened on your landscape, and what happened to it? How is your landscape different after the rain than before the rain? And what happened to that soil? Where did it go, and why did it happen? And this is the time we can explain erosion, transportation, and deposition. In fact, many of our students probably know a lot about that. After the heavy rains we've had here in Florida earlier this year, I swear that I had a lake in my backyard just because of all the rain and the deposition of the different ground that got moved by that rain. So then we want them to elaborate. And at this point, we want them to extend their learning to planning what would help decrease or eliminate erosion. And we want them to design another landscape where they're going to use the same roller plan and resources, but write an explanation of why they think their new landscape will curb erosion. We want them to have them experiment with their new landscape, describe whether or not their plan worked, and have them identify that real-world situation of erosion, what occurred and what's being done. Anything from things like my backyard to, of course, when we have the horrible storms and part of the beachfront along our oceans disappear, all kinds of extension activities that we can do. Then last, but certainly not least, for an evaluation, we can present students with photographs that have different landscapes and have them evaluate whether or not each landscape would be effective in preventing erosion. And in the evaluation, you're going to want to make sure that they can define and use the terms that they have learned in this lesson. 5 steps, very easy to teach one major concept. And if you say, but I think I need more materials, there again, we have some great resources for Earth and Space Science. If you've never visited the Environmental Protection Agency, that agency has fantastic lesson plans for you to use in the classroom, along with specific teacher guides that give you a step-by-step on how to teach those using the 5 E's. And Susan and I tell people never forget Discovery Education. Another great website, and you'll notice that we've given you here the URL for Earth and Space Science. So you have 4 very basic ideas on how to use the 5 E's and even more resources. But let's take a look at the resources that we have in your guide. So Susan, if you will take us through what I pull up their handout.
Yeah, just a couple of things as you're thinking through all of this and as Bonnie's moving over there. Think of the 5 E's, as Bonnie said earlier, with your planning document. It really allows you to make sure that, that we're going deeper into the different materials for students so that they have a better understanding of the different topics. As we said earlier too, don't think that you have to do everything at once, or that you're going to be able to cover everything. The reality is that you have limited time, so let's take advantage of that. As Bonnie moves through and scrolls through the workbook, you'll notice on page 3 you have more information on the high impact indicators. Notice that on that right-hand column, what you need to look for in students' work. And that's something we need to be really cautious about, that we're making sure that our students have a basic understanding within these different areas. And not just to pass the test, but to be able to use that information later on. The next thing you'll see is on page 4 is the scientific themes, and you have that information just as we did within the PowerPoint. And then on page 5, it's lesson planning strategies using the 5 E's, and this gives you a little bit more information that I think will be helpful to you about what is happening at each one of those different areas, as well as the purpose as we look on to the next page and look at the chart, and also the role that I take as the teacher. What is it that I need to be doing? That's going to be very helpful in your planning process as you move through, and that you'll see on page 6 and on page 7. As we indicated earlier, on page 8 you have some questions that are already constructed there. So what are some questions you can use for explore, explain, elaborate, and evaluate? Each of those different ones, it gives you a starting point. Now, of course, that's not to say that that's all the questions that you certainly need, but it gives you a really nice starting place with that. The next one is actually a planning document for you. Where you go through and you figure out, okay, I'm going to take on this topic, and here's how I'm going to get them excited. Here's where they're going to do a little exploration. These are the things that I need to explain and get into that conceptual understanding. Here's a chance for them to take that and apply it. And then finally, how will I evaluate? Again, you're not looking to develop an elaborate lesson plan, but rather make sure that we're hitting those points so that we keep our students engaged. On page 10, you have the different shapes of paper at scientific inquiry, which falls fastest. So students can identify what their independent variable is, their dependent, get their if-then questions going, and of course we've got to collect the data. So there is a sheet there, and then they can draw their conclusions from that. And then last but certainly not least, because I know all of you always look forward to the different resources that are available on the web, we've tried to provide you with some materials that we think you will find very useful. Bonnie has mentioned several of these, the ASC Chemistry for Life. One that we didn't talk about specifically today, but certainly is high on our list of priorities in terms of looking at resources, and that's Annenberg. And you can see the habitable as well as force and motion. Bonnie pointed out the EPA. Come on, let's take advantage of these resources that are all there. And then don't forget that what you may want to be finding in different cases, maybe it's something that students are going to read and have to be able to draw evidence from. And as we've talked in earlier sessions, Musella, wonderful site, and of course it has 2 categories in there that deal with science. So let's take advantage of that. And then last but not least is Teachers Try Science, which again, free. And Bonnie, you know us, we love free. Free and engaging lessons that we can use in the classroom itself. So having said that, Bonnie, I think we need to see if anyone has any questions. Your mics are all muted, so what we will ask you to do is there is a question panel, and if you have any questions, please feel free to just type those questions in, and we will answer those to everybody as we're going through. If you don't have a question specific to science, but it is something about the GED test itself and you want to ask, then please feel free to do that. We have a few more minutes before our time is up today, so we'll give you a little opportunity to do that while, Bonnie, you go through and provide just a few final thoughts.
One of the things that we will tell you, because I've gotten a couple emails from the field, and that is the aspect that although there have been some score changes on the GED test, science continues to have two short answers. They have not removed the short answer questions from science. One continues to be a short answer that requires students be able to read and make connections with what they've read, sometimes assess a scientific principle or theory. The other deals with some type of experimental design. Remember that these questions may look different from what we see in our books or what we see on the item sampler, because each short answer question has a different rubric that assesses it, but they are short answers. One of the things that Susan and I have found when we look at the 5 E's and the types of questions that each of those areas is asking students to respond to, that's a great way to teach students to more closely read and to be able to draft short answers to answer such types of questions. So again, short answers have not removed themselves from science, nor has any of the content areas of science changed. It is still a very rigorous test with not only close reading of scientific articles, but a basic understanding of some of those big ideas of science, which is why Susan and I chose the types of topics we did today to show you how you could create lessons using the 5 E's. Those are big ideas of science that students should understand, and they connect very well to the real world. So again, don't forget, short answers continue. The same areas of assessment are still there. None of that has changed on the science test, even though such things as social studies, extended response, has been removed as of yesterday. So, Susan, any questions?
No, we have not had any questions. This is a very quiet group today. I think they're all just taking in the information and probably trying to figure out, okay, how am I going to implement those 5 E's as I'm going through? So let's take one more look. If you're interested in accessing any additional GED materials, then again, as Bonnie mentioned earlier, make sure that you go out to Florida IP Day and check on all the things that are coming, because we will be having some GED modules, Bonnie, coming up soon. Some distance learning courses that will be, they're short, sweet, and we'll cover a number of different points. Lisa, thank you so much for your kind words. We really appreciate your being here with us today, and glad that these resources and the information is going to be useful to you. One other place that we want to always recommend that people go when you're looking at the GED, and always to stay updated, is to look at the GED Testing Service website, because they continue to add materials, whether it's professional development materials or they're adding more information as we've seen all of the changes coming through. So you want the most recent and up-to-date information that's there. So having said that, Bonnie, I'll turn it back to you. We don't have any more. Oh, yes, we do have one. Sandra James, Thomas Jefferson Laboratory has excellent periodic table activities. Okay, guys, we need to make sure we keep that one in mind. Thank you, Sandra, for sharing that with us. That is one of the things that we appreciate most, is that all those resources that we find maybe sometimes stumble across, and having an opportunity to share those with others.
Okay, then on behalf of June Raw, who's in transit, Susan and I would like to thank you for being with us today. Please continue to check in on Florida IP Day. And as you look through today's webinar, we're going to reiterate one more time. Take a couple big ideas and teach them deeply. Don't think you have to use 5 E's for everything, but we promise you that those big ideas that students need to know, if taught through the 5E process, will not only basically integrate into what they are doing for a test, but more importantly, transition to what they are able to do in the real world. So guys, thank you very much for being with us today, and we hope to see you again soon. Have a great rest of the week.